that we have seen till now, they're all inference problems. All the parameters of interest are given to you. Okay, you can compute the optimal policy without actually doing a single action in the real world. There is nothing you need to learn. Everything you need has been given to you. Okay, now what exactly did I get? What I got is this model. Yeah, what I got was this, this model. So I got the observation model, I got the action model, and I got the reward model. I didn't have to actually wait to get into the state to feel the reward that state will give to me. That's reward model. I didn't have to actually do the action in the real state to see what is the probability of getting into different states. That was given to me upfront. And then finally, if I'm in POM-DPs, I didn't have to actually, I have an idea, a prior idea as to which observation I'm more likely to get. Remember, after 2 observations in O1 and O2, I knew this is 0.7 probability, this is 0.2 probability. I knew it beforehand. That was because I was given the observation probabilities. So when we say that POM-DPs and MDPs are pure inference models, that means the parameters are given to you. And everything you need to do is combine the parameters to compute the optimal policy. In the real world, parameters are not given to you in some problems. You know, it's like either the evolution has equipped you with the transition probabilities, the reward probabilities, reward models, and the observation model, or the evolution just equipped you with, quick pair of feet, so that if you get into a bad kind of a state, you start running. And then remember. Do you understand what I'm saying? So more likely than not, what happens is, you may not have the model. And for us, model essentially means, as I said, reward model, action transition model, observation model. Of these, in most of the reinforcement discussion, we'll assume we are looking at MDP worlds. That means fully observable worlds. Which means observation model is irrelevant. So all I need is reward model and the transition model. If I happen to have it, then I can use that to compute the optimal policy. In particular, I can compute the optimal value function from which I can compute the optimal policy. In reinforcement learning, you are not given those. Just because you are not given that doesn't mean that if you are actually in that state, you won't feel the reward. So for example, a kid is not given the reward model that if you put your hand on a stove, you will get a big negative reward. But when she or he puts the hand, the world will oblige with showing the reward. Then if that kid has to survive until and go into the next grade, they should remember next time. Otherwise they'll be keep putting it on the stove, and after a while they don't have hands. They may not be a kid also, but that's a different story. Okay? So the point is, you need to learn the reward model. So you need to learn you'll get the reward. The first time you feel the reward, you can actually remember it. That's how you get the reward model. And then you can also learn the action model. By, every time you do an action in a particular state, you see the occurrence probability that a certain state is occurring. So you need the brain, because every time you do, only one of the states happens. But over a period of time, you have to realize, last time I did, the tossing of the coin, I got heads. This time I got tails. So it looks like it's half and half. Or last 20 times I did, I got, 13 heads and 7 tails. So it's 13 by 20 and 7 by 20. That's the transition model I learned now. Now I got the transition model, I got the reward model, so I can combine them to come up with an optimal policy. That's where the problem is. The problem is, basically, when do you know that you got the full transition model and the full observation model? Because in a true reinforcement learning scenario, you don't even know all the states up front. Until you fall into that state, you don't know that state. So there is a huge temptation to say, enough, okay, I have already completed 5 years of top quality education, I'm done with the elementary school, let me start exploiting my education. Okay, find the optimal policy for what to do with my 5 years of education. Okay, which particular tire of a car should I be cleaning for the rest of my life, and find out. Okay, and that would essentially be exploiting your existing model. And then once in a while you need to also explore to see the rest of the state space. And exploration doesn't have a direct consequence on your immediate happiness, but it has a huge consequence on your overall happiness. So one of the most interesting and beautiful trade-offs that reinforcement learning makes you come face to face is exploration versus exploitation trade-off. That's because the model that you currently have is only based on the states you have seen. And if you compute the optimal policy based on that, you may never go into certain states. And once in a while, as they say, you have to walk on the wild side to figure out what's going on there. And then you might run away. That's a different story. Okay, if there's interesting stuff going on, you have a chance of learning and then improving your model to be more complete. So those are the issues that we'll talk about in the next 2 classes for reinforcement learning. Except we will do this in the context of fully observable MDPs. In fact, they should really be done in the context of POM DPs, because you only get partial observations even when you don't have model. But it'll make our lives simpler. Okay? That's it.